Hello everyone. In this video tutorial, I'm going to show you how to start working with Midas Gen software. So Midas Gen software is one of the leading software for structural engineering design. And recently, a lot of update is made, and I like to introduce you this software using a series of tutorial. So this is the first time you will face, and if you don't have this software, you can request a demo, or in a third party, you can get a crack file. So here is the interface. We have menu, and also we have a toolbar and other some shortcuts. uh, when you start this not exist, and you will see this one for start page. We go to start a project by new file, and in the new file you will be in the here is GUI, global coordinate system, and you will model here. You also can create a user and then turn it to the global. So that doesn't matter, and you can start in the global coordinate, also in the user coordinate. In case if you want to do 2D, you can go to structure type, and here is the structure type you can consider. So what I want to consider the XZ plane. This is X and this Z plane. So this is a gravity loaded gravity acceleration is already given. It's okay. So I created in a 2D form. Now uh, the next is creating some properties. So here is come to the material properties, and you can select the first material. So I used steel material, and steel using ASTM unit. So here is the list of the material. So I used A36, and so all the parameters giving is okay. Because we just used linear, we didn't add any plasticity behavior. Now in the next is section, we want to define a section. So we use IP section, which is European code standard. Here is the giving I section. We're using IP 300 for the column, and 350 for the 330 for the beam. Now here in section name, you can go to down, and here is the IP section. So the first is 3. We're gonna call apply, and then is 330. So what just we have two section. Now we don't have any shear wall or slab, so we don't need the thickness. Close, and now we want to create a grid line. In the structure, we can go to grid line. Here is two kind of grid line you can introduce. One is using a point, which is distributed point across this area, or another is just a line. In the line, you can go to add and give a name. Let's create line 1, and in the X, I want to add how many? 2. So that 2 is 2 number at 5 meter. Now here is, and I want in the Y, because we don't want to model in the Y, so we want to add. Now I can go to add, and the same, or just 2 at 5 in the Y. Now okay, and this is the grid line which we created. Next, we want to create the node element. So I can go to create element, or you also can define node. Now using IP 330 for the column and 3 for the beam. Here is the you can select I select this point to this point and this point to this point. Now I can close it. I can go to select this 3 point. Here is some toolbar, then you can use it for the selection and selection. Now I select this 3 point. I want to go to the extrude. So I want to extrude this 3 point to the node, to the element. So here it's save first tutorial. Using the first was for the beam. Now I'm going to using this one for the column. Here is the extrusion. We are going to extrude it to minus 3.4 meter. Apply, and you can see here it is. I can go to here and see this is 2 section. Now you also can here check display the node elements and also node. This is element 1, element 2, element 3, 4, 5. And here is the perspective. You can see how it is perspective view, and also you can turn off. And also here is the extrusion. And okay, now we want to off this one and go to back. Here it's called select all. I'm going to select all this one. I'm going to here, or you can use this translate. Here is also translate. So what I want to translate all these beam columns using to Z 3.4 up. Apply, and here is. Now next is we want to define the boundary condition. Here is in a boundary condition you can select by using single nodes or using window to select the node, or also you can use plane. In define support, I'm going to restrain all the rotation and deformation. Now you can see here is the next is we're going to apply some load. So first we want to have the self load and a live load and also a lateral load. In the static load case, we want to define first dead load. From dead load, you can give it dead load, and again we're going to go to live load, and the last one is called lateral load. Here you can select user interface. This is user defined. Now it's okay. Now what we want to do is we want to define the first self weight. Self weight is a dead load in a negative -1 z direction. So the second one is element load, which is the live load. We select these 3 beams, and I'm going to apply minus 10 kilonewton per meter. Sorry, it's dead load, and I'm going to select this one, and here is one. I can undo, Control C, and I can go to live load and selecting again these 2 elements and applying a live load. So the last one is here is called nodal load. In the nodal load, I can go to the lateral load and applying 100 kilonewton to each these 2 nodes. Now you can see all the load is applied. So everything is finished. There's no need combination. Combination in the Midas Gen will happen after the analysis. I'm going to perform analysis. And here is the result. It's called solution terminated. Your job is successfully completed. So this is it, okay, without any error. Now what we're gonna do is we're gonna go to again height and the line and with the result, and we want to, in case if you want to create a combination, you can combine after the analysis, but we will not do this. Just we want to see the response of this. First is going to moment reaction force. Reaction force and using dead load, and you can select any of these. Let's see the dead load, the live load, in a total of fxyz. You can show the value and also considering the legend in a right side. And here is the data giving. Next we want to go to the force, and here is beam diagram. Now we want to get the moment from live load, and it can be contour and also value and also legend. Now apply, and you can see here is the, and obviously you can manually calculate, and the result is 95% correct, same with manually calculated. Also we can see some stresses as well, beam stresses, and from live load. This time I want to consider the lateral load. So let's see. Apply. We can show, and now you can see the stress. This area is in the middle, which is a loss of stress in this area concentrated. When you're pushing, this area is going to tension, and these two columns are going to end up compressive. So in tension and compressive. And in case if you go to deformation from the lateral load, go to volume, legend, apply, and you can see when we're pushing, this area is going to be stretched and this area will be compressed. So you can see in case if you want to find a specific node, and you can go to search displacement, and here is giving. Now you can see dx dy. I want to use now millimeter to see properly the deformation. Again, apply, and you can see it's about 33 millimeter or 33 millimeter deformation. And also we can see the strain, applying a strain. And this is the strain, and we can go to the height. So the strain is because it's an elastic, so we don't have too much strain. So now we go back again to the beam column moments, and we can see again, we can from bending diagram, and we want to see the lateral load moments, and here is, you can consider a solid element, and you can see like this. After this finished, you can go to the design. You can go to design, and here is different element design option. We want to consider the design, and you can say design code, which code you want. In case you want Euro code, you can say Euro code, and some other parameters, but mainly we're not going to design this, so the design can be for the next time. because in the next time we want to create a very larger structure and applying different combination, and then we will conduct the design. In case if you want, so then just go to here, still design, or here, preform batch design. You can conduct it. So this is the end of the tutorial. See you next time. Hello everyone. In this video tutorial, I'm going to show you how to design a truss structure in Midas Gen software. In a previous tutorial, we have modeled and analyzed a portal steel frame. Now, the second tutorial, we want to conduct a truss element design. So this is an example. We can create what we want. This is already designed element, and we imported to the Autodesk AutoCAD. So we have this Midas. You can go to create a new model, and you can change the unit as you wish. So I use kilonewton meter, and there is 2-3 way to model this. You can bring the AutoCAD file, or also you can create node elements, but I'm going to show you the very easy way. You can come to the structure. Here is called truss. In the truss, you can select which type of truss you want. So I want this kind of truss, or other kind of truss you want. So in case if I want this truss, so the length required is how much. So I want this required length should be 12 meter. Now how much the height you want? So this is totally 24 meters, because I want to use symmetric, use this 1 and 2. So now, so the peak should be 4.8 meter, 4.8 meter, and the number of panel in this 12 meter. So we want to 1, 2, 3, 4. If I go to back here, you see 1, 2, 3, 4 panel. 1, 2, 4 is in the bottom, which is panel has 3 meter. Now this is okay, and I'm going to okay, but we couldn't define the materials there. Instead, we can also use here and select material. Now we can go to material and using which code you want. So I use ASTM. In the ASTM code, you can select the material you want. I want A36. Okay, in the section, I want this truss. The bottom should be T section, and the top code also should T section, and the diagonal truss bracing should be L section or angle section. So we have two kind of section. Add. We go to the here in the T section using ACI 10. Now you can select. This is WT. You can select. This is 265. This one is for bottom and top chord. It's automatically taken, and we go to check the angle here. Here is the angle. This is double angle, and yeah, this is angle, and I'm going to select 230. Let's use this one. We're gonna go to OK, and we have two section. I'm gonna close it. So what we're gonna do is I want to select the diagonal section. I can go to here. This section, and instead of I'm going to work here, and I'm going to drag and So now the L section is added. Next, I want to add some vertical, because there we cannot create. I want to add some vertical member as well. So I'm going to node create, and here I want the vertical should be also T. I'm going to select here and here and here and this one and this one and this one. Sometimes we should see how this beam configured. So this one is not correct, the bottom one. So I want to select the bottom chord. I want to select the bottom chord here. I want to rotate this by 180 degrees. Yeah, it's gonna save design truss. Now here in the here is called we can go to called material. Yeah, change parameters here. You can go to change parameters, and what I want, change element parameters. So what we're gonna do is we want to assign this is the section, no, element local axis. I want to rotate this to by 118. Now you can see it's changed. If I go to again, and it's exactly what we expected. What we expected. So this is the correct way. Now I go back and create the modeling is completed. We're going to create some boundary condition and define boundary condition, and I want to use this boundary condition for the two end nodes. The second is close. If I go here, and you can see here is some relays, some relays is made. Actually, the top chord shouldn't have any relays. If I go to here, properties, and it's called this is relays. So I'm going to add this is fixed, so no need. And the second is also, I'm going to here to see this also shouldn't have any relays, because the top chord is directly fixed. So the only relays is allowed in the diagonal and vertical members. The last one here is going to be what's going on here. So this also should be okay. Now I want to select the diagonal members. And this is it. So I want to assign a boundary condition here. It's called end beam release. Now what I want to do is I want to release I want to release moment y. You can see here actually this is node 1, node 2, and we want to this moment. You can see this is moment y, z across y, and this is x, so that should be x, 0 in the both direction. Apply, and we can see here is the moment is released. Close, and we that one shouldn't be 0. Now we are okay. Now you can see the release is showing in the all members. Next we go to the load and define some load cases. The first one is date load, which is consists of the self load, and other is live load, which is the roof load. Even you can ask roof live load, but it's okay, the live load is same. Now in the self weight we define this, take the load as a self load -1, add, and we go to the node load and select all the nodes. We actually even we don't have some time load here, but we want to add some load. We want to apply a negative in a z direction, -10 kN. Apply, and you can see here this is finished, so nothing else. We're going to go to analysis and perform the analysis. Yes, the analysis successfully completed, and we're gonna go to the results. And in previous video I also said one difference between Midas Gen and another software is the combination is after the result, so you can create a combination. So now I'm going to give a number 1. Yeah, I give number I can call com1. So the com1 is called active. You need to add type. You can just add, not using SRS or something else. And this is the load case you want to add is date load, and the factor you want, I'm going to use 1. And the second in the same combination using L or F is 1. Now the second combo, com2, using also active. Oh, sorry, I should select steel. That was general, so I should give now again name com1, and here is I should use serviceability design or strain. So mostly it's using strain stress analysis. Now you can select date load 1 and live load. Here in the first one, live load 1, sorry, here date load 1, live load 1, and the second one is strength stress the same, combo 2, giving 1.2, and that was, this should be live load, and this is date load, and this is 1.6. So we created these two design close. Now we're gonna go to the result, and let's go to the reaction force, and here is the reaction force, and we want to create C from date load. Creating values, and you can see this is the reaction force in X and Y. Now we can go to the deformation, and also using the combo 1, combo 2. Actually we have one more combo. I'm going to back to see the combo, which 3 combo. This is from general, so we want to delete this one. This one is no need. I'm gonna go to delete it. So that one is deleted. Just we have an steel 2 design. Close. And now I can go to here, C2 combo 1 was 1, and we can see the deformation of this truss. So like this you can go to the see the force from combo you can apply, and this is the force, actual force in these members. So this member is 0, so these are the member. One is tension, the green line is negative, this is negative, so it's compression, and this is the positive, that's a tension. Now in the part of design, we go to the design. In the design we check the code which based on the which code you want to design. So I want to use ACI LRFD. Okay, and next I go to the define a material. Usually this is called material, and you should say select this material and call edit modify. Okay, and now so this is very simple. We're not considering any earthquake analysis to define some extra factor. So just we want to check based on this giving load. So we're going to start code check. Now it's start to design the structure. So the structure design is completed. Now it's giving, so according to mem property, all is passed in according to the members. You also see all this member is passed. So in case if you want to check this member, you're going to connect, and it's a graphic. Now it giving show you the calculation, and this is the member actual member force, actual force, and all calculation, all check, and also everything is passed. Now you can save H1. So in case if you find there is some member that didn't pass, you can go to recalculate and change the data. Now I can it create me some graphics, and you can see the members. The ratio is, the maximum ratio is 0.3, so which is less than 1, which is the acceptable. Like this you will design, and after that you can export to DXF file, and you can create all the data. Sorry, it should be frame thickness, center line, frame shape, frame thickness, everything you can check it. Now I can save it, design truss, and I go to back to design truss and open it. Now here is actually the enter. So this is it, and this is 3D. Now I want to create a visual style, and I can give a shaded. Here is. Now you can create a drafting for this one, and finally prepare the document for your client. So this is the end of tutorial. If you have any question, please put in the comment, and I will find time to answer you. And we have a series of such tutorial, and later we will have from intermediate to advanced. See you next time. Hello everyone. In this video tutorial, I'm going to show you how to design a complete steel structure in Midas Gen. In previous tutorial, we have discussed very simple models. So in this time, we want to create a multi-story structure, steel structure in Midas Gen. So we go through to the modeling. We can create a new file or new project. Here we have 2-3 options to create such a structure. Even you can bring from DXF file a plan of that structure, and then you can create elements, or you can create nodes and this will be very traditional method, and also but in some specific structure that's good. So what I want to do is I want go into the structure, basic structure here, and I create a frame. In the frame, I want to that in the x direction is a 3 bay, which each bay has 6 meter to length. The repeated is 3, which is called 3 bay, and this is the height of the structure. So each height is 3.6 meter, and the total is 5 stories. Now I can go to add X code and I add Z code. Now here is the structure. One frame is created, and next going to the edit. In the edit, I want to select this one here, and I want to add the material. We're using this time the European code and using steel 335. And so OK, and the second using same for the section using HB 300 and HB HB 400. Now we have two sections, 300 is for column and 400 is for beam. Now close this, and we don't want to apply any slab, so just let's do section properties. Okay. Now here is I want to create generate frame, and this is the frame generated, but the section is taking for all 300. So later I can change to delete that section. And also here is the element. I also can here delete the element. So now this is the first element. You can go to this element, and you can this element. I can quickly delete this element, and here also delete. So this bottom is no need. Now I'm going to apply, and it's created. One thing I can quickly go to here, select the beam, so I want to change the beam section to 40. Here is the section, and this is section. Just drag, and it automatically changed. Now we want to select all, and here is the element, and I want to go to translate. Translate, I want to select the entire structure, translate in here is giving the distance. So this direction is Y. If I go to a little zoom, now you can see this is Y direction, and I'm going to give Y direction is about 5 meter. 5 meter in a Y direction. The repeat of the time is the same with X direction. I'm going to apply, and you see it's 3 other frames created. Now what I want to do is I want to go to the one of the views. I can select just nodes, even the frame also well selected, so it's okay, just one is okay. Now I can go to the element, and this time I want to extrude. So I want to extrude. It requires me to save. I'm going to call Midas frame design. Extrude this is node to element. So this is the column. I'm going to using 14, and it's in a Y direction by 5 meter, 0, and how many repeats? So equal to 3 base. Apply, and you can see we automatically created a structure in a few seconds. Now we go to the next. This is finished. We go to the boundary condition. In the boundary condition, first of all, I want to select the bottom of the structure. Use select by plane, and I select x, y, giving 0, and I'm going to select apply, and all the boundary in the bottom of the node is selected. Now what I want to do is I want to define boundary condition, and I want to consider fix in all direction. So the next I want to define loads. We have a dead load, which is including the self load and live load, which is the floor load, and also ex the seismic load. In even I can consider one direction because yeah, two direction, because one direction is more steep, one direction is less, x, and also adding y. Now the first, go to the load. Here is the load, and first I want to apply the self load in a -3 direction. Going to add the second other load, a live load and dead load of the floor, is going to apply here. Going to assign floor load, but before that I should create some type of load. Let's call it roof, LL plus dead load. Here in a class I should select dead load in the first one, dead load, which is total dead load. Extra dead load is -2 kilonewton, and live load is -4 kilonewton. Now we added already, and I'm going to OK, close, and here we got that roof, dead load, live load. And so what I want to do is I'm going to the one of the direction, and here I want to select this floor, and here is the command is called active. Just it will show the selected active file. Now actually in this slab is two-way slab. Now I want to use the two-way, and you also have another option in case it's one way, you also apply. Now here is defining load area, and it's called me copy floor load to the upper load. So the distance from one is 3.4, and here is actually wanting z copy or populate to the upper stories. Now I want 4 more stories at 3.4. Now I can go to select node here, here, here. Now you can see all the load is applied in the floor. Then it automatically changed to the beams, and this is a little better or good option from Midas Gen. Now we finished, and I can go to right click, and here called active all, activity is called active all, and all the structure is added. So now you can see the load is applied into entire structure. So now this load is finished, and we want to define the the first one was created in the okay, that just dead load, live load is okay. We can go to in the live load we didn't define, but in the dead load we have one floor load. In the first load case, I should say that floor load case. Now I can, in case if I want to uh, properties, and I can delete that live load. But instead of this one, I can call it date plus live load. Now this is self load, and also this is floor load, because this floor load is including the date load and live load. Load case EX, which is earthquake. In the load, I will go to the seismic load and define seismic load. So the seismic load, I want to use IPC code 2019, and here is the site class. So the DS is stiff soil. We want to use B, and this parameter, the short period of ground motion is 0.17, and this okay. When I give this one, this other automatically will calculate it. Now this is important factor is 1. I want to select this first one is for steel structure, okay, this one, okay. And one more thing I should say, this is a still moment resisting structure, so I'm going to give 8 and give this time period, and this is just in Y, and oh sorry, but before this I should go to here in the load. I should change loads to masses, because when we want to create a shear force, so the program automatically will calculate for us. So now I want to consider the load factor for date and live load 1. So okay, now we can go to back to again to load, and here is going to seismic load, create EX. The code is IBC to 10, and this is going to be 1. Let's make a little larger to get more shear force. And the risk category is 2, important factor is 2, and approximate time using the first one for steel structure. Oh sorry, one more thing which is not creating is going to the story. Here we should create the stories, otherwise the structure will not generate force. So okay, so we created the force. The program will detect the height of the structure there. Going to load again, seismic load, and this time we will create again IPC 10, and let's give 1, and this is 4, and 1 factor, this is 8 for steel structure, you can check, and just it's in the X direction. Giving the time period is this one, okay, and it's calculated. In the Y should be 0 now for the time being, and now we can see the force is created here. So the bottom, I'm going to force apply, and we go to the second one. Same criteria, same properties, but this one should be again, and this is 0, and this one be 0, this be 1. And I can go to C. This load is giving in the Y direction. Okay, and we created 2 load. Now the load is also applied, and this is the center of mass. The next is going to the analysis. I'm going to perform analysis. Yeah, analysis so fast, about 2 seconds completed, and now we want to go to the result. But before showing the result, we should create some combination. So we're going to auto generate combination. We're using you can use lateral resisting force design, also allowable stress design. So I go to use allowable stress design steel, and I can call Some factor for seismic design you can consider, but just I will set this default, and I'm okay. Now we created let's see, this one is 0.1 and it's minus 50%, so we have another one. All this combination is giving this on the code. Now we can in the results we can see some let's see the reaction force, maximum XYZ, and I'm going to here you can see maximum, and here is giving the maximum minus 400, the moments also, and this is the X 231 132. So like this we can check another list the deformation from the EX, apply EX, this is it. And if I uncheck this, you can, or I want to see animation list with rendering, you're going to apply and you can start the animation. So this is the force which is created animation, and also we can see in the Y apply value. So the maximum is about in the node 91 about minus 100. Very it's actually meter because it's very small. We're gonna go to C millimeter and I'm going to apply again, and you can see here is about 40 millimeter, and it's about 40 millimeter and 0.8 millimeter. Even I can go to search node and I can go to see this point is dy is 12 millimeter, and this one also. Here you can see the deformation. Now we can also go to see the some stresses in beam column during the earthquake. Applying this one, you can see the contour. Here is large, here is large, and top is least, which is green. Now we can go to the design. In the design we can select design code, so we want to use that ASD code. So we don't have any bracing, we check it, we didn't check the bracing. Go to again, and this time because just get familiar with the design of steel structure, I will not deal with each parameters. Just for simplicity, I will change the materials and also the design code. Here I'm going to call steel design, modify steel material. In previous I give A3015. In case if it's not available, you can change which steel you want. If I want to 275, and then just modify, and then again go to the steel design and call design check. We just click check control number 6, and the design is starting. Now member is checked. The design time and also analysis time is quite fast, and give you a very reliable result. So this is both is passed based on this loading criteria, and now we can check the member, and you can see all member is giving. So the entire member is okay. You can, just as example, I want to select this one and I want to connect showing the summary of that selected column, and here is the checking is passed, combination, the moments, share, everything, and finally it passed. Oh, one more thing, and I'm going to here select graphical, and it's better and a lot of information, including which checking we should consider. So the slenderness ratio is important. It's checked. The axial strength, so it's beam, which is no need axial strength, so it's become okay. Now the bending is so the measure bending is come from beam, so here it's checked okay in two kind of beam, in X, Y, and Z. Also the tension plus bending check, and the shear strength also checked okay. Now the deflection check is, so the use this equation. In case if you think that equation is not enough, you can change. So using this one is about 60 millimeter, so which is 0. Okay. And so this the final is, in case if you are not satisfied with this, you can go to back to the design and still, and here is called optimal design. So it will start to optimize the proper section and material for you. Now it's finished, and you can instead of that, so this is optimal. In the optimal there is some technique. Let's select this one and select this 13, and then you can analyze option or column design, because that's column, so when you're using which force you want actual force including moments, so okay, and again it will start to design for you. It will create a different iteration, so then give you a proper result. Now just in analysis option you can actually give so number of repetition. So for one repetition this check is okay. So in case if you have 2, 3, or 5 section, then you can do for each one optimal design, and finally you can find a proper section. Now the last one is we can export this to as a DXF file, AutoCAD DXF file, and you can consider all things. Export DXF file, and so I want to open the DXF file quickly. And now here is the DXF file. And this is it. So just I want to use visualization, visual style, and you can see now here is, yes, if I go to the front, and you can see the beam column beam column frames, and like this. If I select, this is here, which is center to center, in case if I want to bring it to back to here. So you can consider to provide drafting or shopping in this and also you can make scheduling as well. And we need to design the connection, and so the connection also we can directly use here in the tool, use the design plus, or also it's quite uh, integrated with other software. Let's export with IDEA Statica file, and also IFC file, and also Revit file. Revit file here is not. I think in the tool you can find. You should have a plugin, then you can sit there and you can provide the connection design and as well as the shopping. So this is the end of the tutorial, and if you have any question, please put in the comment. I will find time to answer you. And next tutorial will be using response spectrum analysis and also concrete structure, considering shear wall, and also basement, other structure. See you next.